Yeah, thank you, Maren. I'm just going to attempt to share my screen, but thank you for that intro, and thank you for the support from the PHRN to actually get us to this point. It's very exciting. We've got this in production now. So let me see if I can. Screen. Over there. Can everybody see that? On PowerPoint. No.
Not yet.
Not yet.
Not yet. Sorry, I'm used to Teams, not Zoom. Let me put that over here. Screen.
Yep, that's coming through. And can you put that in slideshow mode?
Yep.
Excellent. Done.
There we go. Just over here. So thank you, Maren, again. My name is Mark Sipthorpe. I'm the Technical Manager in the Centre for Victorian Data Linkage. I'm joined today by a few colleagues. Hopefully they'll be able to answer some questions as well, but I'll get started. So Vault is our secure research environment. We've been developing this cloud-based secure research environment for several years, for a couple of years, with the purpose of accessing de-identified linked data sets via virtual machines. This enables it to be held within the CVDL technical environment, which is inside the Department of Health. Many other data linkage authorities have similar secure research environments, and we'll be hearing from them today, which I'm very excited to hear about. And the reason we moved to a secure platform is to enable higher compliance with privacy legislation and information management standards than previously possible, where we were providing the actual raw data or raw unit record data to researchers and policymakers. So the release of linked data goes into our secure research environment for approved projects and approved researchers. And this contributes to stakeholder confidence in terms of data use and appropriate use of that data. It's become very important, I guess, to move this way with the significant number of projects that have come online over the 5 years I've been there, and since CVDL's formation in 2009. We are currently doing, hundreds of projects a year. So that would be hundreds of subsets of physical data being provided outside the department, where we wouldn't have any auditability or, to know where they are and how they're being used. This gives us the confidence and the public the confidence to know that the data is secure, it's being used correctly, and it's being vetted in terms of the publications that come out of it. So the platform had been in beta for several months and was used by selected users. We got a fair bit of constructive feedback around that, and we made those changes. Vault is now in production, and the feedback has been very positive. The platform that's still in there, but was implemented progressively. We've got a soft launch at the moment where we've enabled, I think there's about 20 projects on our Vault environment to get a bit more feedback before we make sure before we roll these out even wider. The CVDL cost recovers for these VMs. We do that based on this VM use, CPU and RAM usage. There's a calculator that can give you the Azure costs for this, and we pass that on to the researchers for access. And this is customizable down to the hours of use that machine's on during the day. So cost is usually estimated at the time of application with consultation with the researchers to know how and when they'll be using it. CVDL abides by or follows the 5 SAFEs framework: safe people, safe projects, safe settings, safe data, and safe outputs. The secure research environments and Vault actually pertain to the safe settings. That's most relevant. However, they do play a role in safe data, and the safe outputs of that data or outputs in terms of tables, graphs from those secure and research environments. We went with a cloud-based repository for this and analytic tools. We have a great deal of data sets inside our integrated data resource. We wanted to, I guess at the start, wanted to have a separate sandbox or environment for each project to be able to enter their project, to manipulate their data or their bespoke cut of data without interfering with anyone else. This also now allows us to abide by the privacy and security legislative requirements and compliance. The data, most importantly, from a departmental point of view, is held within the cloud environment, within the department's control. And alternatively, the benefits to the researcher are that we give data science tools, Python, Stata, SQL, and the speed of these machines can be increased far more than your average CPU sitting on a desktop. We can scale these up and down according to requirements on any given day, really. And there's a cost recovery model we've implemented to do that, really just passing those costs on for the per hour use of that VM. So we've built our cloud environment, our secure research environment in Microsoft Azure, and there was a number of reasons for that. Number one was security. So first and foremost in our minds is the security of that data. At the time, Microsoft Azure was the one of two, maybe, that were IHub certified. It enables multi-factor authentication, data remains within the VM, and internet connectivity is limited. So by that, I mean, we haven't shut the internet down completely, as there are programs like Python that do need some controlled access to function correctly. Arguably, Microsoft is the most ubiquitous platform, I guess, in the world. It has got a very familiar look and feel to people. I mean, a lot of people are Microsoft based. The scalable computing power was a big benefit to us. We wanted to offer the ability to look at these really complex and large data sets for researchers and be able to do that quite quickly. We wanted to give them the greatest tool set available that we could. So at the moment, we've got R, Python, SQL, Power BI, and a few other products working up there. There is a roadmap to look at other products and getting them working. But in terms of that, we need to bring them in, make sure that they don't do anything to our security infrastructure, and test them. And we also have machine learning. This is just a couple of screenshots from the Vault environment. So to access it, it's just an RDP, a remote desktop connection, where you'll be given a username and details for the computer. And when you log onto a VM, it looks just like any other Microsoft desktop would. And you've got all your tools and your data will be sitting in that environment for you to use. Just to give you a bit of an idea of why the Azure performance is so compelling and so great for researchers, is we had a complex piece of Python code and we ran that on a desktop machine with, I think it had 1 CPU, 8 gig of RAM, and it processed in 2 days. And that was, if it didn't fall over, there was no errors in the code itself, but eventually we got it to process in 2 days. We took the same piece of code with the same data to one of our VMs and we scaled it up significantly and gave it 32 CPUs and 256 gig of RAM and processed that same piece of code in 2 hours. Meaning that there's large efficiencies to be gained here for researchers where they can actually run a piece of their code in 2 hours. And if the output isn't as expected, they can make some changes and run it again. So meaning they could do that potentially 2 to 3 times a day to get the results, rather than the old way would be, it'd be weeks to get that same result with the manipulations. So there's a big benefit there. I think there's a benefit all around in terms of data security and governance, and it's working very well. As I said, the feedback's been great. But keen to hear some more questions and be able to answer them for you. But if you'd like to talk to us, there's our email address. Thank you.
Excellent. Well, thanks very much, Mark. I know there'll be some questions, but we're going to hold those to the end. And just thanks for sticking to time. And we'll now move forward, and I'll introduce Craig, who's our next speaker. So Craig's a Senior Program Manager at the Australian Institute of Health and Welfare in Canberra, and he's been there for nearly 3 years. He's responsible for development of the IHW SHRAE environment, and he's going to tell us about that cloud-based environment. So Craig, over to you.
Thanks. I'll share my screen first and see if this works. You'll see that. Everybody's got it? Beautiful.
Yes, we can see that. And can you put that in slideshow mode?
Yep, there we go. Let's have a look. There we go.
Yeah, that's right.
So I'm just going to do a similar thing to just give a quick overview of what SHRAE is, how we designed it, and some of the challenges we've come across as SHRAE has been used for the last probably 2.5 years now. As an overview, it's a secure access environment. We built this on top of Amazon Workspaces, and we've built it off the bare bones installation of what is the Erica platform, which is supplied by the University of New South Wales. It's designed as a cost-effective platform for sharing data with external and internal researchers. So as a general overview, it works very similar to most secure environments. As you have a shared virtual private cloud environment, which is controlled by a data controller. And in that environment, you have a shared workspace, and you have researchers who can access virtual machines, again, using that two-factor authentication that was mentioned earlier. Files flow in and out of that workspace through what we call curated gateways. So essentially, a researcher can offer to have a file ingressed or egressed that through a portal, and that file is held in the EHub or the IHub until it can be reviewed and approved by the data controller. The data is then transferred to the shared secured environment, or out of the shared secure environment if it goes the other way. And that way we maintain that auditability and control of what comes in and what goes out of the SHRAE workspace. The workspace themselves are completely severed from the internet. We don't allow any contact at all. You can't print, you can't screen share, you can't access your email. There's literally no contact at all with the outside world once you're in there. This is just, I won't go into too much detail here. This is just a bit of a summary of the differences between the EHub and the IHub. The EHub is where you upload and download file requests. So a user will upload a file request or download an approved file that's exiting the environment. And the IHub is really where the controller goes internal into the SHRAE environment to approve or reject any requests made by researchers for ingress or egress of files. And this is sort of pretty standard to most secure environments. I think we'll see this pattern throughout the presentations today. But what I sort of really want to focus on are some of the challenges we've been facing of recently, because SHRAE was developed a couple of years ago now, and it was initially designed to hold small data assets and individual projects, but that's sort of changed in our needs now. We need to start holding much bigger, larger data assets in the hundreds of gigabytes and terabytes sort of range. So we've had to start developing some solutions around that integrate with the SHRAE platform. How do you store, manage, and search these sort of environments while still meeting your governance and supplier requirements? And the first thing we did was we mapped out a lake. We developed a data repository essentially a data lake in Amazon now, which is accessible to individual projects through what we call our Views platform. This is now in a proof of concept state. We have some data in our lake, and we have about to start onboarding some users. The Views functionality will allow us to provide some governance about what individual projects can and cannot see, so that we can ensure we meet our supplier agreements about the security of their data, essentially, so that users in projects are only really permitted to see the data that they are allowed to under their ethics agreements. And yet we can still maintain those secure gateways if there's anything extra that needs to come in. This has been a bit of a challenge, but we've implemented this using Amazon Athena, essentially to supply that Views functionality, which is Amazon Athena is an AWS software as a service serverless query engine using SQL. So it interfaces between the projects themselves and the data lake. The other big challenge we've had is what tools to supply, because as Mark said, you can't query massive data sets when you've got a 2-core 8 gigabyte CPU. It's really just asking too much of things. So we've had to sit down and have a really good hard think about the tools and the way we're going to do about this. Obviously, we supply R, Python, and Stata in its native form as well. A lot of these are memory bounded. So, for example, the R and Python can only process as much as they can hold in the RAM of the virtual machine, which is a challenge if you've got 200 gigabytes and you've only got a 32 gigabyte machine. There are ways around this, obviously, with software coding and chunking, but it becomes a bit of a challenge for some of the less experienced analysts. We've looked at SAS as well. SAS is a bit more flexible in that regard, but it does come with its own set of challenges, and it's an incredibly expensive solution as well. In particular, in Amazon, SAS doesn't really play well. We've had a lot of challenges in integrating that, but I'll get onto that shortly. This is part of our, as Mark said, he was talking about tools like Python and R using internet access. Particularly to download packages and update. We've taken a different approach to that. We tend to vet the packages upon user request. This is a quick summary of how we go about that. It's mostly reputation and code checks. And following on from that, there's a lot of behavior monitoring and notification to see if we get any unusual warnings or things attempting to get out of the secure environment. Based on that code. It's one of the problems we found with open source packages is anybody can really put anything in them, and they really do need to be vetted just to make sure that we're not introducing anything into the environment that could be a threat to the security. On the other side of things, we've got commercial packages. We have had some challenges with these as well in getting these into SHRAE. SAS in particular has been a bit of a challenge because AWS natively uses a server operating system for its virtual machines, which SAS does not permit for its desktop clients. SPS, again, also requires some internet connectivity in order to install a machine. So we've had a lot of issues with those, trying to get installations of those into SHRAE. We do have an installation of SAS at the moment, which is working, but it is very limited, unfortunately. We have had a lot of hair pulling and grey hairs over that one, let me tell you. We've also started looking as a way of getting around some of those challenges of analysing data sets and using memory bounded software applications. We've started investigating some of the more inbuilt tools with Amazon. So things like software as a service and platform as a service. Amazon Sagemaker, we're now running some trials on doing some machine learning work with our data lake based on Amazon Sagemaker. Amazon Athena, as I mentioned, is our main tool for accessing that lake that we can filter down. Couple of problems or issues we've discovered with these is cost management is a problem because you don't really know how much something's going to cost until it's run. And we're still getting a bit of a grip on that. And the other thing is the skills gap is a lot of people are very unfamiliar with these tools. They're used to R, they're used to Python, they're used to SAS. It's something that we're going to have to spend a bit of time training people on, but they do offer that scalability that we're really looking for as a potential solution. And that's really about all I've got. I've kind of feel like I've rushed through that, but yeah, it's a bit of a summary of the state of where we're at the moment. We've got our data lake in production now, and it's working, and we're starting to use that to filter down the various views to users. It's now becoming the biggest challenge we're facing is finding the tools and techniques to best access and manage the computational capacity of those data sets we've got there now. So
Okay,
I will open that up to questions, I guess.
Well, Craig, thanks very much for that presentation. That's been really helpful. It's always helpful to understand the challenges, and it's really good because I think you've presented them in a very easily understandable way. So we will have questions, but as I said, we're going to hold those over till the end of the last presentation. So I'm very pleased now to introduce Matt Gorringe. I think most of you do know Matt, but for those that don't, Matt's the Director of Research Assets at the SACS Institute in Sydney. He's been at the SACS for nearly 6 years, and he manages the Sure environment. He's been doing that for the whole time that he's been at the SACS Institute, so he knows a great deal about it, and he's going to share that experience with us today. So over to you, Matt.
Thank you, Marion. Thanks for the great introduction. I'll just share my screen. Can everybody see that one?
Yes, that's good.
Yep.
Excellent. Thanks for the opportunity to provide an update on Sure. It's been great to hear from Mark and Craig as well, and so it'll be a good discussion once we finish this one. So for some reason I can't advance. There we go. So the Sure update, impact and recent growth. This has probably been a big challenge for us, the sheer number of people using Sure. So since 2011, there have been 227 research projects done in Sure. There are 136 currently active and more than 500 researchers currently using Sure. One of the great advantages and things we've been able to enable is not just the use of linked data that might not otherwise have been released to researchers, but we've been able to let researchers collaborate with international colleagues because we know the data all remains in Australia. So that's a good achievement. And, you know, we're quite sort of conscious now about the fact that we're able to supply researchers with a turnkey service and to maintain a full service desk for them. It's something that increasingly researchers have been talking to us about as something really important when they're using one of these systems. And I'm also pleased to say that we got recertification for ISO 27001 this year. That was a involved process, but it's part of our commitment, I guess, to testing ourselves against established and recognised standards for our information security management. Yeah, so the recent sort of annual growth rates of Sure have been a big challenge, both in terms of scaling infrastructure, but perhaps more in terms of how do you efficiently administer your safe people and safe environment for so many people when it's growing so quickly. So I think I started in Sure in just after or at the end of 2016 with, as you can see, 150 users. So to grow to over 500 now is quite a big step during that period. I thought it might be interesting here to talk to people about how people use Shore, particularly because there is so much emphasis on the users that require really high-powered virtual machines. It was just worth noting that the majority of our users are working on project-specific minimised data sets, and most of them are very happy using their 2 CPU cores and 8 gigabytes of RAM. We do have 97 users who are using a Power Virtual Machine, which is a standard virtual machine with 16 gig of RAM. And then we have 21 of those 520 users who are using custom virtual machines, where the biggest one we have is currently using 128 gig of RAM, 12 CPU and a terabyte of fast scratch disk space. So I think the point there is that for most people, standard virtual machines are appropriate. We do know that the people who are using these really big custom ones are working on repository style data sets, or on I think one of them's got all of the MBS and PBS records back to the year 2000, something like that. So they are working on really big data sets. And it's good to be able to provide them that power. We have seen recently some requests for people to apply deep learning, machine learning techniques, and just recently some people who will actually be able to make use of GPUs. So we've got probably 3 projects on the books at the moment where we will move to support them with GPUs in the future. There are lots of other people applying AI and machine learning techniques that don't require the use of GPUs. We have a lot of custom software applications, more than just the SAS, SPSS, Python and R that we provide as standard. And we're also now providing Linux virtual machines for people, and typically that's for open source or user developed specialist applications. Some of you may be aware of the Shore Enhancement Project, which is funded by the PHRN under the RIP program. Late last year and early this year, we went out and interviewed 50 different data custodians, users and potential users of secure data access systems. I've summarised the findings here, though I hope in the future we will be able to make a better report available to people to understand what users said about their requirements. I think the most consistent theme that came through was the desire for greater flexibility, both in computing power, but also in how the services and fees are structured so that they reflect the changeable and uncertain nature of their research projects. I can remember people talking about not being able to get analysts at the time they thought they would, or somebody being on leave and wanting a service that was ultimately flexible, where they were able to turn it off and on whenever they needed to do that. And the other thing that came through, I think, was the desire to reduce waste by being able to share code and by being able to reuse data. And I think being able to reuse data is something that secure data access systems are only partially able to address. I think that this is a larger data governance and ethics question about being able to share data for similar projects. I just note that most users thought Shore did offer good value for money and was fit for purpose, but a minority of users believed it was too expensive or not powerful enough, and that's something we've moved to address. So from the 1st of October, we reduced our fees for using Shore. We got rid of our Workspace setup fee that was previously $2,000 per workspace. We introduced 3 new standard offerings for our times power virtual machines. So we reduced the cost of the Power VM, which had been a previous standard, from about $5,500 to $3,500. And we introduced the 2 times, 4 times and 8 times Power VMs that we modelled on some common virtual machines that were available in AWS. You can see that we're offering all of those virtual machines for as little as 1 month, so that people can use the high-powered machines to do their data management and subsetting tasks, and then drop back easily to a more standard virtual machine at lower cost when they want to perform analysis that doesn't require so many records normally. The enhancement project is ongoing. So in response to what we learned in the consultations, we are committed to providing a secure sandbox in the first instance for a release of synthetic MISI data. And this would be really important for researchers to be able to play with the data set that, while not representative in terms of the relationships in the data, does show the variables and the format of those variables, and lets them even start writing their code before they go and commit to either an application or to engaging a particular analyst to work on the data. So that's something that's been one of the items of flexibility that people have wanted for a long time, is to be able to explore the data, not necessarily for its content, but for its format before they make an application to use the data. We'll deploy GPUs. We're just about to buy a GPU node to support those small number of projects who will be able to use them effectively. We're going to enhance the file access logging that we're deploying. At the moment, we log all the files coming in or out of Shore in the curated gateway. What we'll apply is file access logging. And I think implicit in that is additional reporting to support data custodians understand how people are using their data. So I think that'll be a really powerful reporting tool once we've implemented it. And we're also scoping the automatic upload of data from trusted data custodians, and this is particularly going to be initiated with SANT Data Link in support of the CCDL, Custodian Controlled Data Repository, CCDR, sorry, Miro. We think that could be a very powerful tool where you have repetitive uploads of data on a monthly or even more frequent basis. And of course, we are continuing to make enhancements to the curated gateway. We've moved to a different supplier for that, and I think we're going to be looking at some really good enhancements that will help curators, which means data custodians and researchers, to be a bit more efficient at that point where they want to remove output from Shore. Just for people here that might not know that we offer project model workspaces, it's a slightly different model of service provision. We developed it for the ATO. It's now in use by a few other data custodians, and it tends to be used where the data custodian is releasing their data without necessarily linking it to other data sets. This model doesn't preclude linkage, but it's most sort of popular where someone has data they haven't released to researchers before. And the popularity of it is that we allow the data custodian to in effect sponsor researchers by maintaining a Shore workspace and paying for that Shore workspace, and for researchers to then come and access data sets at a reduced cost where they only have to meet the cost of the virtual machine. So that's a win-win-win, I think, the project model workspaces. It gives custodians confidence because they can remain curators of the data, and so they have great confidence in what is going in and out of Shore, and therefore what the researchers are doing. So it has encouraged a lot of new data sets to be made available just in the last couple of years. And that's it. Thanks very much.
Okay, well, thanks very much, Matt. That's another fabulous presentation, and thanks to all our three speakers. So I think you've shared the good and the bad of the sorts of things you do and some of the challenges that you've had to face. So I'll now throw it open for questions. So if I did notice that there was nothing in the chat, I had hoped that there'd be some active